The diversity of biobank datasets has been under heavy scrutiny in recent years due to an overwhelming proportion of individuals who are largely of European ancestry. Data collected from 2008 to 2023 encompasses around 70% of individuals of just European ancestry, while the 30% is left over for all other ancestries. And this is out of hundreds and thousands of individuals. Admixed individuals, or individuals who are from multiple different ancestries, is even less, around 4% of individuals. Typically, these admixed individuals are left out of studies because they don't fit neatly into these predefined arbitrary ancestry categories that have been set. This can lead to biases, and more importantly, racial biases in interpretation of these multi-ancestry cohorts. Additionally, excluding these individuals from studies limits our understanding of the underlying health disparities or environmental effects that we see, like socioeconomic status, access to healthcare, and access to education. This can lead to biases in prediction of a health outcome for these admixed multi-ancestry cohorts. Traditionally, multi-ancestry cohorts are split up into their individual predefined ancestry categories and analyzed separately. The resulting distributions and diagnostic thresholds that are set are then standardized so that there's one distribution and one diagnostic threshold. This is an ad hoc way to create risk predictions for multi-ancestry cohorts and can lead to misdiagnosis, overdiagnosis, and underdiagnosis of these individuals, along with reduced reliability in our risk predictions. I'm studying how the underlying environmental effects contribute to risk predictions for these multi-ancestry cohorts. I'm using the most diverse data to date from the All of Us dataset to show how using diverse and multi-ancestry cohorts can strengthen our risk predictions for everyone. Using both theory and simulation, I'll conduct genetic risk predictions using simulated individuals, traits, and environmental effects that are then drawn from this data set to understand where the underlying bias is coming from in our current statistical methods. Once I know where that bias is coming from, I'll use that knowledge to then correct for the bias that we see in our current statistical methods to then accurately predict risk for these admixed individuals. Furthermore, I'm developing tools and methods to correct for this bias that we're seeing due to confounding environmental effects to then accurately predict risk for everyone, not just admixed individuals and not just individuals of European ancestry, but all individuals.